present XNAT-PIC, a desktop application for annotating and uploading preclinical images to XNAT. Well, in preclinical imaging centers, different imaging techniques such as MRI, CT, PET, and so on are used for studies. So we have raw images specific for each imaging modality. And we can organize the studies in different ways. For example, we can compare two different groups, a treated group versus a control group, for example. But all data needs to be stored and often analyzed. The analysis is usually done using in-house scripts written in Python or MATLAB. And we have different users such as master students, PhD students, who usually do experiment and analysis. But the data and the results are often stored in their PCs. So repositories and platforms are very useful because they simplify the storage, the processing, and reuse of imaging data. Here, a list of platforms used in preclinical imaging. We have BRAT that provides users tools for recording, analyzing, and translating biomedical imaging data, and Small Animal Chez-Noir, that is an extension of Chez-Noir to support small animal imaging studies. And then Saber, that is a proposed design for a data management platform in preclinical research, and then Pixie, that is a free and open source XNAT plugin designed to support preclinical imaging. But we have some limitations in preclinical imaging because data don't fully comply with FAIR principles. For example, image datasets are stored in local databases or desktops, so they are difficult to find, and then access is restricted to dataset owners such as PI or collaborators, and there is a lack of metadata implementation and description of processing steps. And we have some limitation also in preclinical systems, for example, about costs, because commercial platforms are designed to support common preclinical workflow, but the adoption is limited due to cost, or some preclinical imaging data management platforms are not well known or widely used within the research community. And we can have some limitation about IT expertise because complex installation and setup requirements make some tools difficult to use for researchers without IT expertise. So our aims are, first of all, to develop an easy-to-use, free and open source tool that provides an intuitive workflow to facilitate the management and annotation of preclinical image dataset. And we want to support the preclinical imaging community, and we think that the adoption of these tools will improve the findability, accessibility, interoperability, and usability of preclinical image datasets. So for this reason, we have developed XNAT-PIC, that is a free and open source Windows desktop application to extend the functionality of XNAT. XNAT-PIC simplifies the annotation and uploading of image dataset to XNAT. And the XNAT-PIC core functionalities are MRI to DICOM converter to convert images from raw data to DICOM standard, an uploader to upload images to XNAT, and an interface for grouping annotation. But what is XNAT? XNAT is an open source imaging informatics platform with many features. You can upload, share, download DICOM images, and the access is safe, of course, and you can search datasets. You can run complex processing on your data using the power of high performance computing, and then XNAT supports the integration with the OHF viewer that enables comprehensive visualization of the imaging data. And the XNAT community is very active, and this is very important. And now some technical details about XNAT-PIC. XNAT-PIC was developed in Python, and we used different packages, for example, TTK Bootstrap to design the interface, and then we used XNAT-PI that exposes XNAT functions, objects as Python objects, of course, and then we used PyDICOM, NumPy, and other packages. Well, what are the XNAT-PIC features? XNAT-PIC is a standalone software that has a user-friendly interface. There is an interface for grouping annotation. XNAT-PIC has a DICOM converter for Bruker, and you can upload project, subject, experiments that contains DICOM images to XNAT, but you can upload also non-DICOM files to XNAT. And XNAT-PIC is available for download directly from our website. Here there is the QR code that you can scan, and you can run XNAT-PIC without additional setup. And we have designed an interface easy to use that facilitates the user interaction with the system. And here we have an example of the main interface of XNAT-PIC with its features, the DICOM converter, the uploader, and a button to open an interface for grouping annotation. The access is secure because credentials to connect to an XNAT instance to load images dataset from the desktop client are protected by a cryptographic algorithm. And well, in preclinical research, that data are often structured based on the specific scientific question of interest. So we have cohorts regarding 10 points because you can repeat a position over time to analyze changes. Or we have cohorts regarding groups because you can compare two different groups, for example, a treated group that receives, of course, the therapeutic intervention versus a control group that remains untreated. And we have cohorts regarding drug administrations with varying doses. So we have designed an interface with features that allow users to easily group and categorize information regarding preclinical dataset. And here in this example, we are adding information about group treated in this case, 10 point post 10 days, and dose equal to 1 milligram per kilogram. And then the capability of XNAT to manage different imaging data structure has been expanded to manage 10 points, groups, doses by using custom forms. The figure on the left shows a project in XNAT, and this project contains 3 subjects, subject 1, subject 2, and subject 3. And for example, subject 1 has information about group treated, dose 1 milligram per kilogram, and 10 point post 10 days. And if we open subject 1 in XNAT, we have information about group dose at 10 points, and then there are the DICOM images. We used multi-core processing to improve the conversion speed of raw MRI file formats to the DICOM. And for example, for one project that contains 42 subjects, 42 experiments, that are 650 MRI scans. It takes 6 minutes to convert the whole project. And XNAT-PIC Uploader allow you to create new project, subject, experiment on XNAT directly from XNAT-PIC. And if you create a new project, you can add a project title, of course, project description, keywords, investigator, and then you can upload the entire project or a single subject or experiment to XNAT. But you can also upload non-DICOM files such as parametric maps, result to the XNAT platform. And here the figure on the right shows you DICOM files and a folder called resources in XNAT that contains parametric maps and a TXT file. In conclusion, we want to provide tools that facilitate the management and sharing of preclinical image dataset using the XNAT platform, and we want to improve the discoverability, accessibility, interoperability, and usability of preclinical image datasets. And for the future, we are planning to expand the number and type of custom forms to improve data flexibility, of course. And the second point is that XNAT supports multiple imaging modalities such as MRI, PET, CT, all of which are currently supported in XNAT-PIC, but we would like to incorporate more imaging modality by introducing new data types. So thanks to the team, and thank you for your attention.